Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Optical activity of a mixture depends on the net rotation produced by all optically active species present. A racemic mixture, equal amounts of enantiomers, is optically inactive because the rotations cancel exactly. A mesocompound is also optically inactive due to an internal plane of symmetry. Moving on to the next step. Analyze the given information. The aqueous solution of A and B, which are stereoisomers of each other, shows optical activity, meaning there is a net non-zero optical rotation. Moving on to the next step. Evaluate option B. A and B are enantiomers. If A and B are enantiomers present in unequal amounts, the solution would still show optical activity, net rotation is not equal to 0. So this is possible, provided they are not in equal amounts. However, consider option B alone. If A and B are enantiomers, there is a specific scenario where optical activity could still be observed if they are unequal. So option B is not necessarily impossible on its own. And for the final step, evaluate option A has two chiral centers, B does not have any because it has a symmetry plane, i.e., B is a mesocompound. If B is meso, it is optically inactive. A has two chiral centers and is chiral, so A is optically active. The mixture would show optical activity due to A alone. This is entirely consistent with the observation. So option A can be correct. Re-evaluate option B more carefully. If A and B are enantiomers, they rotate plane polarized light by equal magnitude but opposite directions. For the solution to show optical activity, they must be present in unequal amounts. Option D would then also be true. But if A and B are enantiomers present in equal amounts, the solution would be a racemic mixture and optically inactive, contradicting the observation. The question asks which possibility cannot be correct. Option B states only that A and B are enantiomers, without specifying equal amounts. But stereoisomers that are enantiomers, if the solution shows optical activity, they simply cannot be present as a racemic, equal mixture. Being enantiomers alone does not prevent optical activity if amounts differ. The key reasoning for option A being the answer that cannot be correct, if A has two chiral centers and B is a mesocompound, has a symmetry plane, then A and B are diastereomers. They are stereoisomers but not mirror images. B being meso means B is a chiral and optically inactive. A being chiral means A contributes optical rotation. The mixture shows optical activity. This is perfectly consistent. So option A can be correct. The question asks which cannot be correct. Option B. A and B are enantiomers. If they are enantiomers and the solution is optically active, they must be in unequal amounts. This is possible. Option B can be correct with unequal amounts. If B has a symmetry plane, meso, B is not chiral and has no chiral centers in the effective sense, but wait, the statement says B does not have any chiral centers because it has a symmetry plane. A mesocompound does have chiral centers, stereocenters, but the internal symmetry renders it achiral. So saying B does not have any chiral centers because it has a symmetry plane is chemically incorrect. A mesocompound has stereocenters but is achiral due to internal symmetry. The statement in option A incorrectly equates having a symmetry plane with having no chiral centers. This is a factually incorrect statement about stereochemistry, meaning option A as stated cannot be correct because if B truly had no chiral centers at all, it would not be a stereoisomer of A, which has two chiral centers. For B to be a stereoisomer of A, B must have the same connectivity and same number of stereocenters. A meso compound has stereocenters but is achiral. The description in A is self-contradictory. B cannot be a stereoisomer of A with two chiral centers while having no chiral centers at all. Therefore, option A cannot be correct because if B truly has no chiral centers, it cannot be a stereoisomer of A which has two chiral centers. A meso compound has chiral centers but is made achiral by the symmetry plane, so describing it as having no chiral centers is wrong and internally inconsistent with being a stereoisomer of A. Therefore, the correct answer is A. Therefore, the correct answer is option A.